Hey guys, welcome back. Welcome to Vedantu's JEE channel. How are you all? All my students who are moving from 10th standard to 11th standard, कैसे हैं आप लोग? Well guys, as you are aware, this is a series that is exclusively being launched for students who are moving from 10th to 11th standard. Yeah, I'm sure many of you have already taken a decision to prepare for engineering entrance exam, that is JEE. So yes, that series that we have launched is basically for you. But then there are many students who have just now appeared for their board examination and are still wondering or rather are confused, and they are thinking that what exactly should I do after my 10th standard examination results will come. So guys, I know that the 10th standard results are still at least 2 months away from here, but still we can utilize this time to start exploring how things are going to be if we take science for 11th and 12th standard, and how engineering entrance examination preparation is going to be. Okay, so if you are still not sure, still I will recommend for you to keep on coming for these sessions. Okay, so guys, let me start by introducing myself for people who are here for the first time. This is me, your Suri Sir. Yes, I'm also known as Mogambo. Why is that? Is because when you will crack the examination of JEE 2022, then Mogambo Kush hoga. Okay, guys. Well, this is our third session of this unit, which we call as units and dimensions, or you may find it to be written as units and measurement as well in some of the books. Okay, guys. So I'm here with all of you guys, and if you guys are here for the first time, I have a lot of information to share with all of you. Starting off with the timetable. Yes, have a look at all the faces which are there on the screen for all of you guys here. Yes, this is your very own Love Sir. This is me, your Suri Sir, and Arvind Sir. Very important for you to know that every Wednesday and Saturday you will have chemistry lectures. Yes, Love Sir is going to teach you chemistry. And like today, Monday and Friday at 7 p.m., you are going to have physics lectures with me. And on Tuesdays and Thursdays, you're going to have maths lecture with Arvind sir. Okay, guys. Apart from that, we are exclusively keeping MCQ sessions as well for you on every Tuesday, Friday, and Saturday at 8 o'clock. So, guys, remember, important timings for you to remember is 7 p.m. and 8 p.m. 8 p.m. timing is important on Tuesday, Saturday, and Friday. Apart from that, every day at 7 p.m., stick to the channel. You will be learning something with respect to physics, chemistry, or mathematics for your JEE preparation. Okay, guys, I hope things are clear. And yes, if you're here for the first time on our channel, guys, do subscribe to the channel as well. Okay, apart from that, you know that right now we all are under lockdown, nobody is able to go out. But as I'm sure you are aware about, Vedantu's app and the entire content on Vedantu is free, and also on top of that, on Vedantu's platform, the enrollment for JEE 2021 for the students who are preparing for 2021 has also become free. Okay, guys. So you can come for students who are preparing for JEE for next year, that is 2021. Guys, come to the channel, enroll for free. Cool, guys. People who are new, as I told you, do subscribe to the channel. Okay, guys, this is our JEE channel. I want you people to subscribe to the channel right away, so that you are not and never missing out on any information that is related to JEE or that is related to any engineering entrance examination. Okay, guys. Well, let's start. Welcome back once again. As you know that the chapter is chapter number 1 of 11th standard physics. This is units and measurement, or units and dimensions also. And already in the previous two sessions, we have covered a lot of things. So previously we were speaking about the usage or applications of dimensional analysis. We have already talked about the usage number 1, which is to check the correctness of an equation. Very important usage for us because it will be very helpful in solving a lot of MCQs as well. Okay, I'll keep on telling you that time to time. Okay, apart from that, yes, the second application was to convert unit system from one to another. I said this also earlier and I'll repeat myself, that not a very useful application. Okay, it actually is a lengthy process, but what we are doing today is basically the third application. We'll be dedicating this session to derive a formula. Yes, how about we'll be able to derive the formula for any physical quantity, for which the information is given to us. Okay, guys. So what are we waiting for? Let's start the third application, which is to derive a relationship among physical quantities. Okay. Now, before I start explaining this to you, obviously with the help of example, I'm going to explain as I've done previously in the session for the other two applications as well. There are certain limitations with this particular application. The first one, I'm talking about the limitations. Okay, guys. So when I speak about the limitations of this application, the limitation of this application is the very first one is that uh, the numerical values, or rather, I should say, the numerical constants cannot be found by using this method. Means what? Say we know that the formula for kinetic energy is half mv square. So you will be able to derive the expression where kinetic energy will be depending on mass and velocity as mv square, but you will not be able to find that half to be present in the formula. Okay, because that is something that you find experimentally. Secondly, uh, equations involving plus or minus sign or plus or minus operator cannot be found. Okay, you cannot derive an expression which involve a plus sign or a minus sign. Like if I tell you any equations of motion that we know from uniformly accelerated motion, v equal to u plus at, s is equal to ut plus half at square, or v square equal to u square plus 2s cannot be derived by using the third application. Okay, and third and the last one is that equations will which involve say trigonometric functions like trigonometric function or logarithmic function, or I say exponential function. Any equation which involve these type of functions cannot be derived by using dimensional analysis application third. Okay, please remember these three are very important points. So we'll be able to derive very simple type of formulae, and I'll try to explain it to you with the help of examples. Okay, guys, stay tuned and try to solve along with me. Okay, let's first see the very first example. It says that this is how the questions usually are being put up. Derive the formula for potential energy represented by capital U of a body if it is found that the potential energy is dependent on mass of the body, acceleration due to gravity, and height from the ground. Okay, so using dimensional analysis, we have to find out the formula of potential energy being the function of mass, small g, and h. Okay, guys. Well, one very important thing before we go forward and start solving the questions by using this, we should know the dimensions of all the quantities which are mentioned in a question. That's a must over here. Okay. So let's try to simplify this. Okay, guys. So how you are going to approach this? First of all, you will say that the potential energy of the body is directly proportional to m, g, and h. But to which power of m, to which power of g, to which power of h, you don't know that. So what you will do, you'll say it is x power m, y power g, and z power h. Okay, that means what? The potential energy formula is m to the power x, g to the power y, and h to the power z. And I'm sure you must have guessed it by now. Our objective is actually to find out the value of x, y, and z will be true. Okay, as you can see, I'm using a proportionality. So if I don't want to use the proportionality, I'll remove the proportionality and I'll put a dimensionless constant here. So m to the power x, g to the power y, h to the power z. You can go and approach like this as well. Okay, guys, remember k is a dimensionless constant. Okay, it's a dimensionless constant. Please remember that. So when I'm going to do the dimensions application, when I'm going to use the dimensions of the quantities involved, I'll not be mentioning k and its dimension because it is dimensionless. Okay, guys, now I hope you remember the very first application of dimensional analysis, which said that if an equation is correct, it must be dimensionally correct. Yeah, and for an equation to be dimensionally correct, its dimensions of quantities on the left hand side and the dimensions of the quantities on the right hand side must be same, and that's what has to hold true when we are deriving an equation. Okay, guys. So what I'm going to do now, I'm going to write the dimensions of left hand side. I'm going to equate them to the right hand side, and then we'll compare the coefficients, or you can say the powers of M, G, and H here, or M, L, and T eventually. Okay. So the dimensions of potential energy is M1, L2, T minus 2, and I know that you all remember them now. The dimensions of mass is M to the power 1. The power of mass is X. Power of G, or other dimensions of G, are L1 T minus 2, because that is an acceleration. Power is Y, and H is a type of length. Power will be Z. Okay, guys. So what you see here, that on the right hand side we have M to the power X, then L to the power Y, T to the power minus 2Y, and L to the power Z. What did I do? I took these power and I brought them inside, multiplied them by the numerical powers which are mentioned. So this is how things look like. So what I'm going to do now, I'm going to just write the expression in terms of M, L, and T. So there's only one M here, so that is power X. L to the power Y and Z is visible, so y plus z, and finally t to the power minus 2y, and that is equal to m1 l2 t minus 2, which is basically the dimensions of potential energy, as you are all aware. Right, guys? Now what I'm going to do, I'm going to compare the powers of m, l, and t. Okay, ready? So guys, what you see, if I compare the power of m here, okay, you see that if I compare the power of m, it is x, which is equal to 1. So I say that x is equal to 1. If I compare the power of L, so L to the power is y plus z, and that should be equal to 2. Yeah. And if I compare the power of t, then t to the power is minus 2y, which is equal to minus 2. That means I can say that 2y is equal to 2, which gives me y equal to 1. Yes or no, guys? If I compare this, it gives me y equal to 1, minus 2y equal to minus 2, so 2y equal to 2. And now put the value of y here. So what do I have? I have 1 plus z equal to 2. That gives me the value of z also as 1. Yes. So guys, coming back, the formula that we wanted was m to the power x, g to the power y, h to the power z. So if I do that, I get the formula of potential energy as k times m to the power 1, g to the power 1, h to the power 1, or you can simply say it is mgh multiplied with k. Yes, we do not know how to find out the value of k. Yes, we know practically the formula is just mgh, that means k value is 1, but with the help of dimensional analysis, you will not be able to find the value of k. Okay, that is something which is found experimentally. Okay, guys, I'm sure you are getting into the groove of solving the questions by this process, and some of you might not be 100% confident yet, so that is why I'm going to take another example for you to understand the process. So this time, pay more attention, pay extra attention, stop writing things on the chat box, rather pay attention to what I'm doing here. Okay, guys? Cool. And there will be obviously towards the end an assignment, and there will be homework question for you. Okay, so guys, next question, what you see here, it says that the centripetal force F acting on a particle moving in uniformly in a circle may depend upon the mass, velocity, and the radius of the circle. So we have to derive the formula for the centripetal force by using the method of dimensions. Okay, guys. So using the same approach, I'll say that the formula for force will be, say, some k times m to the power a, v to the power b, and r to the power c. Yes, you can choose any unknowns as the powers of m, v, and r. But as I said, you need to know the dimensions of left hand side and right hand side. Then only you will be able to find the value of a, b, and c here. Okay, as we know, k is going to be a dimensionless constant. That means it will not be involved while writing the dimensions. Okay, let's go ahead. So the dimensions of force m1, l1, t minus 2. Mass is m to the power 1. You will take its power as a. Velocity is l1, t minus 1. Its power is b. And r is a type of length. Power is c. Okay, guys. So what do I have from here? I have m to the power a, l to the power b, T to the power minus B and L to the power C. So again, just writing as M, L and T, I have M to the power A, L to the power B and C, that means B plus C, and T to the power minus B. Now I can compare the powers with left hand side, that is M1, L1, T minus 2. Okay guys, that means what? On comparing the powers, you can see that if I compare the power of M, I get A value as 1 very easily. If I compare the power of L, I get B plus C as 1. Okay, and obviously still we need to find either B or C to find out the other one. And if I compare the power of T here, I get minus B as minus 2, which means B is equal to 2. So what I'll do, I'll put the value of B here guys, and then what, if I put the value of B over there, then I get the value of C as well. So this is 2 plus C, which is equal to 1. That gives me C equal to minus 1. Okay, that means A is 1, B is 2, C is minus 1. So force, which is equal to K times M to the power A, which is 1, V to the power B, which is 2, and R to the power C, which is minus 1. So if I rearrange this, the formula looks like M V square by R. This is basically the final expression of the centripetal force. Later on in physics, we'll learn the chapter of the circular motion, and that is where I'll be taking you through the concept of centripetal force as well. That is where we'll come across this formula and we'll derive it properly. Okay, this is the method of dimensional analysis. I hope you're understanding now, people. Okay, so this is one of the ways of asking the question by telling you that there is a quantity which depends on say two or three quantities in a row, and this is the approach that you take. But then now I'll tell you how else the questions can be asked, which will involve the same application, that is the third application. Okay, so this one says that, now let's read the question carefully. This is the language which you can expect from the question to have the same type of application. So it says that if force, acceleration and time are taken as the fundamental physical quantities. Usually the fundamental quantities are mass, length, time, current, temperature, amount of substance, like that. But now the question is saying that if force, acceleration and time are taken as fundamental quantities, then find out the dimensions of length in terms of these. So these are the options which are given, and we'll go by the same approach. Means what? You just need to know that this is another way of asking the questions for the third application of dimensional analysis. You will see that my approach is going to be exactly same. Okay, so I say that the length of a quantity, or length as a quantity, will have a dimensional formula as f to the power say x, a to the power y, and t to the power z. Okay, my task is to actually find out the value of x, y and z. Okay guys, so left hand side is m0, l1, t0, and on right hand side I have force, which is m1, l1, t minus 2. Its power is x. After that you have L1 t minus 2, power is y, and third is t to the power z. These three are written back to back. Okay, so guys, the right hand side is m to the power x, L to the power x, t to the power minus 2x, then L to the power y, t to the power minus 2y, and t to the power z. Okay, that means what? Overall, what I have is m to the power x, that's the only m term, then L to the power x plus y. Okay, and I have t to the power minus 2x, minus 2y, and plus z. Okay, and left hand side is only m0, l1, t0. There is only length on the left hand side. Okay guys, that means if I compare the power of m, on comparing m, I get x equal to 0. X is 0. That means it is not depending on force, which means what guys? The option that tells you, by the way, we got the answer directly here, but we'll still find out the other powers as well. Answer is going to be option D for sure, because the rest all the options have some force power there, non-zero. So x is 0, jackpot. Next is if I compare the power of L, x plus y is going to be 1 and x value is 0. That tells us that y is going to be 1, and that actually testifies here. Okay guys, and third one to find out, I have minus 2x minus 2y plus z. Minus 2x minus 2y plus z equal to 0. So x is 0, y is 1 plus z equal to 0. This gives me z equal to 2. This minus 2 will go to the right hand side, it will become plus 2. So that means the formula, the dimensional formula for length is f to the power 0, a to the power 1 and t to the power 2, or simply if I have to write the formula, L is equal to at square. That's basically your answer. Okay guys, very awesomely we got the answer as option D. I hope you guys enjoyed the question. It's a very good question. Okay, let's have another question based upon the same approach. Question says that if you have pressure, velocity and time which are taken as the fundamental physical quantities, then the dimensions of work done this time is to be found. Okay, so pressure, velocity and time are the fundamental quantity. Let's find out the dimensions of work. So I say that work dimensions will be p to the power a, v to the power b and t to the power c. Okay, so left hand side the dimensions are m1, l2, t minus 2. We know the dimensions of work very well. Right hand side is pressure. Pressure is m1, l minus 1, t minus 2, power is a. Velocity is l1, t minus 1, power is b, and time to the power c. Okay, so guys, on the right hand side, I have m to the power a, l to the power minus a, t to the power minus 2a. After that, l to the power b, t to the power minus b, and t to the power c. That's basically what is happening. So if I consolidate it, I have m to the power a, l to the power minus a is here, then plus b is also there, then nothing else. After that, what you see for t, it is minus 2a minus b plus c. That's what I have for powers of all of them. And let's compare them with this. That means if I compare the powers of m, what do I have? A comes out to be 1. First thing first. Okay. If I compare L, then I have minus a plus b equal to 2, and a value is already found, so minus 1 plus b equal to 2, that gives me b equal to 3. Yes or no guys? Minus 1 goes to the right hand side, the value becomes 2 plus 1, that is 3. And finally minus 2a mm, minus 2a minus b plus c equal to minus 2, because t to the power is minus 2 here. So minus 2 into 1 minus 3 plus c equal to minus 2. So left hand side is minus 5, it goes to the right hand side, becomes plus 5. Plus 5 minus 2 is 3. So c equal to 3 is what I get. Okay, c value comes out to be 3. That's what we are getting. C is coming out to be 3. So a is 1, b is 3 and c is also 3. That means guys, the correct answer to this question. Okay, so we wrote about the previous question here. Okay, no problem. We got the answer as option A. Yes, that's what we get. If we write it here, it becomes p to the power 1, v to the power 3 and t to the power 3. That's what is our answer. Let's compare it. Okay, just a second. You can see that. That's what our answer is. P to the power 1, v to the power 3 and t to the power 3. Okay guys, nice. Okay guys, now next question. We have to find the dimensions of a into b if the relation E equal to b minus x square upon at is given to us, where E is the energy, x is displacement and t is time. So this is something that we won't need the third application here. Okay, in fact I would want to come to this question after we are done with another one, because I want to show you people another way of asking the question from the third application. Then we'll go to that question again. Okay guys, let's read the question. It says that if the unit of force is now become 2 Newton, unit of length is now 4 Newton, sorry 4 meter, and unit of velocity, instead of 1 meter per second, it has become 6 meter per second. Then find out the units of linear momentum, that too in kg meter per second. We have to find out the unit. Okay, that means how many times kg meter per second the new unit is going to be. So instead of 1 Newton, now the unit is 2 Newton of force. Instead of 1 meter, 4 meter is the unit of length, and instead of 1 meter per second, it is 6 meter per second the unit of velocity. Okay, guys. So now what we are going to do, first of all, we need the same approach here. First, I'll just try to find out the dependence of momentum on force and velocity. So I say that momentum, that is P, is going to be force to the power, say, x, and length to the power y, and v to the power z. So the momentum is given as m1 l1 t minus 1. Here force is m1 l1 t minus 2, power is x, length is power y, and l1 t minus 1 for velocity, power z. So on the right hand side, I have m to the power x, l to the power x, t to the power minus 2x, then L to the power y, then L to the power z, and t to the power minus z. Okay, so consolidation gives me m to the power x, L to the power x plus y plus z, and t to the power I get as minus 2x minus z. I hope you are following this. Okay, guys, and let's compare it with the dimensions of momentum. So it gives me m. If I compare, it gives me x value as 1. If I compare L, it gives me x plus y plus z as x plus y plus z comes out to be how much, guys? It comes out to be 1. Okay, and if I compare T, I get the value of minus 2x minus z equal to minus 1. So I know the value of x. So in the power of t, if I put that, so minus 2 into 1 minus z is equal to minus 1. So I have minus z equal to 2 minus 1. That means z is equal to minus z is equal to 1, or simply I get the value of z as 1. Okay, guys, I'm getting the value of z as 1 first of all. Okay, now I already have the value of x, I already have the value of z. So if I put the value of x over here as 1, I'm now going with this one. So x, instead of that I'm writing 1, y is unknown, and for z I'm putting as, sorry, z value came out to be minus 1. Okay, let's just erase that part. Let me write that properly for you guys. So I have, from here we got the value of z as minus 1, and now we are putting the value of x and z here. X value is 1, y is unknown, and z value is minus 1. Okay, and this value is going to be equal to 1. So minus 1 plus 1 cancels, so y also come out to be 1. Okay, guys, that means what? If I have the expression of x, y, and z, x comes out to be 1, y comes out to be 1, and z equal to minus 1. Okay, x equal to 1, y equal to, I'm trying to remember so that I can erase it without losing the data. Okay, so the value of x1, y1, and z minus 1. Remember with me, x1, y1, z minus 1. x1, y1, z minus 1. Okay, so value of x is 1, y is 1, and z is minus 1. Okay, that means what? The momentum formula, which was force to the power x, length to the power y, and velocity to the power z, comes out to be p equal to f to the power 1, l to the power 1, and v to the power minus 1, which is basically f l by v. And now you are going to put the limits, or rather the units, not the limits. You're going to put the limits or units of the force, length, and velocity here. Okay, There will come a chapter later on which we call as differentiation, where we put the limits also, don't worry. Okay, so force is 2, not writing it as Newton because eventually the unit that we are getting is kg meter per second. So force is 2, length is 4, and velocity is 6. So if I cancel this, this comes out to be 4 by 3. That is basically the value of units, 4 by 3 kg meter per second, the answer to the question. So guys, the correct answer comes out to be option B. Okay, awesome. Now taking you to this question. Now this question was E equal to B minus x square by AT, and we have to find out the value of A into B. First of all, if you remember, I told you people that two quantities can be added or subtracted only when they are representing the same quantity. And x is displacement, that means B is also a displacement. Okay, that means the dimensions of B are very clear. Okay, if x is displacement, then B is same dimension as x square. So the dimensions of B is L2. And now because I'm interested in the dimensions of A, so that I can find A into B, A becomes B minus x square by E into T, and B and x have same dimensions, so B minus x square will also have the same dimensions, that is L2. Dimensions of energy is m1 L2 T minus 2, and time is T to the power 1. So L2 and L2 cancel. I have final dimensions of A as m minus 1, denominator became T to the power minus 1, while coming up it becomes T to the power plus 1. Okay, I'll write it properly for you guys. This is T to the power 1. So now we can find out the dimensions of A into B. A is m minus 1 T1, and B is L2. That means final answer is m minus 1 L2 T minus, sorry, T plus 1, which is basically, there is only one option with m minus 1. So m minus 1 L2 T plus 1, that is our final answer, guys. Final answer is option B. Okay, we already solved this question, and this one is homework question for all of you. Here the pressure, velocity and time are taken as the fundamental quantity, and we have to find out the work done. Okay, oh, we have done this question, guys, so no problem. I'm going to give you guys another question to try. Okay, let's do one thing. I'm going to give you guys a question right away. Let me cut this down. Okay, say if I tell you that if height h, okay, and density rho, and acceleration due to gravity, which is represented as small g. If these three are taken as fundamental quantity, then you have to find the dimensional formula or dimensions of pressure. Okay, find the dimensions of pressure in terms of height, density and acceleration due to gravity. Okay, this formula is something that we will learn in the chapter of fluid mechanics. Okay guys, do tell me what dimensions you are getting. You can just tell me the answer as in this form, that h is some value, rho, rho is density, okay, not resistivity, some value, and g some value. Don't write the numerical value, tell me the power which you are going to find them. Okay, so you basically have to find the value of x, y and z. I'm interested in finding the value of x, y and z. Tell me the numerical values of x, y and z in the chat box, sorry, in the comment box, not in the chat box. I'll be reading, I'll be telling you what is the correct answer as well. Okay, cool guys. Well, for people who are still not sure how and when the lectures are happening, and you are still missing out on a lot of things which are related to JEE, and you want to be stay updated with respect to your JEE dream, then guys do come to our Vedantu's Telegram group, where we upload the assignments for every session that we take. We give you free notes over there, the study material basically, and you get the daily updates of what is happening on the channel on that particular day. So if you want to become a part of our Telegram group. The link for following and coming to the Telegram group is available in the description of this video, as always. Okay, guys. So do follow and come to the channel's Telegram group as well. Okay, guys. If you enjoyed solving the questions on the third application with me, do hit that like button, guys, and do share this with your friends so that they can also learn and you guys can solve the problems together. And most importantly, if you have not subscribed yet, do subscribe to the channel so that every notification related to the channel is yours on the right time. Okay, guys. So I'll see you again with another session where we'll start with another chapter, as well as there will be an MCQ session coming soon. We'll be solving a lot of problems in MCQ session very soon. I'll be seeing you again. Till then, keep studying, keep smiling, keep enjoying physics, and keep yourself safe during this lockdown. Okay. Bye bye. Take care, everyone.